will use a frequency distribution to organize a large amount of data. If you have a whole bunch of data points just in a list, it's difficult to determine what they mean and what data points are most common and most rare unless you organize it into categories somehow. We essentially want to clump nearby data points together. To do that, we're going to make a frequency table, and we're going to use class intervals to be our categories. From that, we're going to draw a visual representation of our data called a histogram, which is really just a bar graph. Let's do an example. Here we have a random sample of employees of a large company. They were asked to state their commute time from home to work. These were rounded to one decimal place, written down in hours, and recorded in a table. And that's what we have in this list. What we want to do is organize this using a frequency table. We're going to learn about relative frequency, cumulative frequency, and relative cumulative frequency. We're also going to create a histogram and a frequency polygon. We're going to start by making a frequency table to organize our data, and we're going to use class intervals. We have been told what to use for the first class interval, and that's 0.2 to 0.4 inclusive. So we make a table, interval, frequency, and we're going to add the other categories as we need them. Okay, our first interval is 0.2 to 0.4. Inclusive means it includes the 0.2 and it includes the 0.4, the ends. So if it goes up to 0.4, we don't want 0.4 to be included in the next category, and so therefore we are going to have to jump up to 0.5. And we want them to be equal width. If you look at the width of the first category, 0.4 minus 0.2, those are 2/10 units apart, and so we want our next interval to also be 2/10 in width. So that means we're going to have to go up to 0.7, because when we subtract the 0.7 and the 0.5, we still get 0.2, just like we did the first time. And so now we're going to have to go up to 0.8, and once again we're going to jump by 2/10, so that'll put me at 1.0. Ooh, how far do we need to go before we need to stop? We need to look and make sure we find the biggest and the smallest data points in our list so that we don't keep making a whole bunch of categories that we don't need. What's the smallest data point? This is the smallest one I see, and sure enough that falls into the first category that we were given, so that's good. Let's see, what do we have as far as biggest? We have a 1.2, we have a 1.3. Do we see anything larger? I do not see anything larger, so I believe this is our largest data point. So we need to keep going until we get to a category that includes that 1.3. That means we're not done yet. We're going to jump to 1.1 equal width, so we're going to go up to 1.3, and that will include it, and so that will be our last category. Here we are given the number of categories. A lot of times when you run across a problem like this, you'll have to use your own judgment. Too few categories, if you just break all your data into two sets, well, that may perhaps not give you enough information about the data. You'll lose some information whenever you clump them together into categories. So you don't want to use too few. On the other hand, if you use too many categories, if we have a category for nearly every number on here, then we really don't have anything that's much better than what our table is. So it's a bit of a judgment call and a balance between too big and too small. Now we want to figure out how many data points are in each of these categories, and I'm going to do that by doing what I call tally marks or tick marks. If you're not familiar with this, make vertical tally marks, one for each, but then every fifth one you'll lay diagonally so that you can count them in groups of 5. You'll see as we go along. If I start with the first column right here, 0.3 will end up here, 0.6 in the second category, 1.2 in the last, 0.5 in the second category. Now we move to the second column. Doesn't matter if you work in columns or rows, you just want to be systematic. So 0.7 will go here, then 0.2, 0.9, 1.3 in the last category, third column, 0.2, 1.1, 0.8, 0.7. Move to the fourth column. 0.5, now that one I'm going to lay diagonally. 1.1, 0.4, and then 0.6. So now we're ready to do the fifth column. I will let you do it, and I will do it on my own, and then we will see if we match. Feel free to pause the video or fast forward or rewind if you need to. Okay, after doing my tally marks, I'm coming up with a frequency of 7 for the first category. That's that group of 5 plus 2 more. Then 10. Then 6. And then 9, like that. Now, we want to write down our relative frequency. Before we do that, let's check to see how many data points we have. Looks like we have 17, and then another 6 is 23, and 9 is 32. If you check your original data set, you notice we have 8 columns of 4 entries apiece, so that would be 32. So we do have the correct number. You always want to double check your tallies and your frequencies to make sure they're correct. Now, relative frequency means relative to the whole group. So we have 32 in our entire group, so that means our relative frequencies will be 7 over 32, 10 over 32, and you could reduce these, but a lot of times it's helpful to have them all with the same denominators, and that way you can see the relative sizes of each one. 6 over 32. And 9 over 32. Cumulative frequency means that we include the total of your category, the current category, plus all the ones earlier. In other words, the first category will be 7 over 32. Then the next, we're going to take the 7 and we're going to add the 10. Actually, what I started to write was cumulative relative frequency, which is not what I want. I just want cumulative frequency. So that's going to be 7. And then we're going to take the 7 and add the 10. So 17. Another 6 is 23. Add the 9 will be 32. And this should turn out to be the total amount that you had. From here, I bet you already know now what we mean by relative cumulative frequency. So that's going to be all those cumulative frequencies except with respect to the whole. In other words, what portion of the whole will it be? So 7 over 32, 17 over 32, 23 over 32. And this last one, 32 over 32, had better turn out to be 1. If it's not, something is wrong. And actually, we can use this information even before we draw the histogram to answer part C, which is what is the probability that a person chosen at random from the sample will have a commute of an hour or less? Well, which categories have a commute of an hour or less? All of these, right? 1 hour or less. And so those are the people that we want to include in our probability. If we let x be the commute time in hours, then we can talk about the probability that x is less than or equal to 1 hour, and that's going to be 23 over 32. We already have the relative cumulative frequency written down, so we can just take it right off of our table. If you had not already done that, you could just add the frequency 7 plus 10 plus 6, divide by the total, which is 32, and you're going to have it. So this is the answer to part C. Now we want to draw a histogram. And there are a couple of different ways to scale your histogram, and I will show you both. We're going to just need to look at our chart. Once you have your chart, your frequency distribution, you really don't need to look at the original data anymore to do your histogram. What you want to do now is look and see what the midpoints of your intervals are. In other words, what is halfway in between 0.2 and 0.4? Well, 0.3 is halfway in between. That's the way we are going to label our bars. So 0.3, what's halfway through the second category between 0.5 and 0.7? Well, 0.6 is halfway through. So 0.6. Third category, 0.9, is halfway through. And the fourth category, 1.2, is halfway through our class interval. If we make our frequencies go on the y-axis, so choose a convenient scale. 1 unit per tick mark is convenient for me. 1, 2, 3, 4. I'm going to mark this with a 5, 6, 7, 8, 9, 10, and that's as high as we need to go because that's the largest frequency that we have. So 0.3 will be in the middle of the bar that is 7 units high. So I'm going to make my bar about this high, 7 units high, so that looks like it's about right here. The next one will go up to 10 units. So up to 10. Again, we're going to make sure that that midpoint, that 0.6, is halfway through, and a lot of times you'll see the frequencies actually written on the bars like this. The third one, 0.9, is going to go up to 6 units. And the last one will go up to 9 units. Like that. So there's our histogram. Now, an alternative way that you can scale your histogram is also an alternative way to do your class intervals, and this is actually a little more common than the one that I've shown you here to get started with. 0.2 to 0.4, if you look at these class intervals as we currently have them, 0.41 does not fall into any of the categories, and of course all our data are to the first decimal place, so we don't have anything that looks like 0.41. However, we don't want to imply that 0.41 is impossible, because it's not. Any positive real number is a meaningful data point here. Some are more realistic than others, but they're all meaningful. In other words, we don't want to exclude 0.41 or 0.43. So we are going to change our categories just a bit. We're going to write them a different way. Instead of doing 0.2 to 0.4, we're going to write 0.15 to 0.45. In other words, I'm going to bump it up a little bit from the upper boundary and down a little bit from the lower. That way I can start the next one at 0.45, and then that's going to go up to 0.75, just above the upper boundary. Then 0.75 in the next category up to 1.05, 1.05 up to 1.35. Notice that right now we have some things that fall into two different categories. For example, 0.45 falls into both the first and the second categories. However, because our data are all rounded to the first decimal place, we don't actually have anything that looks like 0.45. So we don't have to worry about the confusion that we would get if we had something listed in both. We can't have an actual data point falling into two categories. But here, this implies that there are not any gaps between the categories, and that's actually important. And when you do your histogram, you want to make sure you do not draw gaps between the bars. It turns out that the area under the histogram is an important concept in certain areas of statistics, and so we don't want to mess that up by putting gaps between our bars and implying that there are some data points that don't fall into any of the categories. We don't want that. Make sure your bars all touch. Okay, now if we do our categories the second way that I've shown you, what you can do is on your histogram, we're going to let one tick mark be 0.15 this time, and so then the next one will be 0.3, and I'm actually not going to label that one. The next one will be 0.45 because that's my next boundary point between categories. 0.45, and then I'm going to go to 0.75, then 1.05, and then 1.35. So what we've done this time, instead of labeling the midpoints of the categories, we've labeled the edges. If I do my frequencies, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, so 10. So now I'm going to draw my first one's going to go up to 7. I'm going to label it. Next one's going to go up to 10. Be as neat as you can. Next one, 0.75 to 1.05, and there are 6 of those. And lastly, 1.05 to 1.35, we're going to go up to 9. Now, the last concept that I want to mention here, and it doesn't come up all that often, but you'll see it occasionally, and that's what we call a frequency polygon. Histogram and a frequency polygon. What we're going to do is we are just going to put dots on the tops in the middle of each of our bars, like that. Okay, and so then we are going to connect those with a straight line, and that is what we call our frequency polygon.